So now we come back to another voltage follower circuit that I covered about 4 videos ago and in more detail, but here we're going to look at the voltage with the oscilloscope. So it's a voltage follower. Whatever I set the trim pot voltage to, the NPN bipolar junction transistor will output that voltage and be able to provide power to a load. We do have limitations though, but in any case, first we'll look that we have, there we go, the signal voltage about 2.5 volts, and the output voltage is also about 2.5 volts there. They line up really well, as you can see there. And whatever I set the trim pot to, within limits, the output will follow. Our limit in this case, since the output is the NPN bipolar junction transistor, we cannot get all the way to the positive supply voltage, which is 5 volts. The trim pot can, of course, but not the output of the NPN bipolar junction transistor. Somewhere about 4 volts. Looks like we hit our limit, but anything below that, they're going to follow really nicely there. So we are cascading a PNP bipolar junction transistor and an NPN bipolar junction transistor. So we got our signal there. That's going to the PNP bipolar junction transistor, and that's its output. So its output is 0.6 volts higher than the signal that it gets. So we're doing what PNP bipolar junction transistor emitter followers do good, is take that output and use it as an input for a NPN bipolar junction transistor. And when you do that, the NPN bipolar junction transistor takes the voltage it gets and drops 0.6 volts. So that's just a signal though. It's just looking at that signal voltage. The power is coming through the collector. It passes current as needed to maintain that 0.6 volt drop across a load in this case. So it can provide a lot of power, the NPN bipolar junction transistor, when the original signal is very weak.